Today we'll be seeing about the circular convolution. See, circular convolution is similar to linear convolution, where linear convolution is given as y of n summation m is equal to 0 to n minus 1 if two signals, out of which one is x1 of n and the other is x2 of n. So linear convolution is given by this formula. Y of n is summation m equal to 0 to n minus 1 x1 of m into x2 of n minus m, right? So if I want to calculate circular convolution, what I'll do, we need to just do n here. It means we are convolving the sequences in the circular manner, right? Where n is the length of the given sequence. So there are four ways of doing this, right? One is the time domain approach, one is concentric circle method. The easiest one is the matrix method, and a bit difficult but very important method is DFT and IDFT method, which is also called as Stockham's method, right? So we'll see all these methods one by one. First, we'll deal with time domain approach, right? So let me explain you using an example. Here, two signals are given, x1 of n and x2 of n. Now, clearly the length of the signal is 4, right? So, the formula of circular convolution, as I said, is y of n equals to summation m is equal to 0 to n minus 1 x1 of m into x2 of n minus m to base n, right? So here for this example, capital N is 4. Therefore, I have substituted 4 here, right? So taking this same formula, I first see this is the main formula of circular convolution. Okay, this is the main formula of circular convolution. So our first step is to just insert the value of n in above equation. So I have already inserted here. Now my work is to substitute this n as 4. Right? So when I do this, I get y of n equals to summation m equals to n minus 1, that is 4 minus 1 is 3, x1 of m into x2 of n minus m to base 4. Right? Now my step 2, this was my step 1. Now my step 2 is I'll open up this summation, right? So opening up the summation is nothing but substituting the values of this m here. How many times? 0 to 3. So first one is x1 as it is. In place of m, I need to substitute 0. Dot x2 of n, you keep it as it is. M value we substitute as 0 and the 4 remains 4, right? Plus, now in place of m, we'll substitute 1. So x1 of 1 into x2 of n, in place of m, we are substituting 1. Base is 4. Similarly, x1 of 2, x2 of n minus 2 to base 4. Similarly, m's value we substitute up till 3, right? So this is the equation what we get once we substitute m's value, right? Now what? Y of n. So n value, this small n, again we'll substitute the values of n from 0 to n minus 1, that is 0 to 3, right? So in this equation, right, now this becomes my main equation. So in this equation, substitute value of y of n. So x1 of 0 as it is, x2 of 0 minus 0, base 4 as it is, x1 of 1, x2 of, in place of n I substituted 0, so 0 minus 1, x1 of 2, x2 of 0 minus 2, x1 of 3 as it is, and x2 in place of n I substituted 0, 0 minus 3 to base 4. Next, see the same above equation, I have rewritten x1 of 0 as it is, x2 of 0, this is x1 of 1, this becomes x2 of minus 1, x1 of 2 as it is, x2 of minus 2, x1 of 3 as it is, and x2 of minus 3, right? Okay, what is this? See, now x1 of 0 is okay, x2 of 0 as it is, x1 of 1 as it is. See, when I see the main equation, given sequences, if you see here the given sequence, just a minute, yeah. See, the given sequence is of length 4, wherein index of this is x1 is 0. It means this is x1 of 0, this is x1 of 1, this is x1 of 2, and this is x1 of 3. Similarly, this is x2 of 0, this is x2 of 1, this is x2 of 2, and this is x2 of 3. It means I have both sequences x1 of n and x2 of n. Both the sequences start from 0 and end up till 3. Right? So here, see, now what happens? It means I do not have a sequence, right? I do not have a sequence of x2 of minus 1, right? So in linear convolution, we would have taken this part as 0. But in circular convolution, we don't do this. In circular convolution, what we do is we take 4 minus 1. 4 minus 1 is 3. So whatever sample is existing at x2 of 3, we consider that, right? Similarly, x1 of 2 as it is, and x2 of 4 minus 2 is 2. Similarly, x1 of 3 as it is, and x2 of 4 minus 3 is 1, right? So we'll substitute all these values now. See, x1 of 0 is 1, x2 of 0 is 1, x1 of 1 and x2 of 3. Similarly, x1 of 2 is substituted as 3, x2 of 2 is 2. So when we do this, the answer sums up to 17. So it implies y of 0 is 17, right? So we have done with y of 0. Now our work is to calculate y of 1, right? So this will go on doing until and unless n is done up for 0, 1, 2 and n minus 1, that is 4 minus 1, 3, right? So we'll retain the main formula. This is our main formula. So we'll go on substituting the value of n as 1. So see, this is y of 1, x of 0, x2 of 1 minus 0 to base 4 plus x1 of 1, x2 of 1 minus 1 to base 4. Just see, I'm substituting the values of n, right? Next, x1 of 2, x2 of, in place of n, I'm substituting 1 minus 2 to base 4 plus x1 of 3, x2 of 1 minus 3 to base 4. Okay, I'm just substituting the values of n I said. So I'll get it simplified. x1 of 0, x2 of 1 to base 4, x1 of 1 as it is, x2 of 1 minus 1 is 0 to base 4, x1 of 2, x2 of 1 minus 2 is minus 1 to base 4 plus x1 of 3, x2 of 1 minus 3 is minus 2 to base 4, right? So we'll go on substituting the samples which are available, right? So see, since I have minus 1 sample, see, x1 of n starts from 0, ends to 3. x2 of n starts from 0, ends to 3. It means I don't have left hand sequence, right? So we'll simplify this equation as x1 of 0 as it is, x2 of 1 as it is. Now, since x2 of 1, see, this sample is x2 of 0, right? So x2 of 1 exists. So I'll remove this circular convolution from the base, right? Then x1 of 1, x2 of 0 sample exists. Coming to this, see x1 of 2 sample. See x1, this is your x1 of 0, right? This is x1 of 1, this x1 of 2. x1 of 2 exists. However, if you see x2 of minus 1, see this starts from index 0. So x2 of minus 1 does not exist. So what we'll do? We'll do 4 minus 1, which is 3. So x2 of 3. Similarly, x1 of 3, keep it as it is. This becomes x2 of 4 minus 2, which is 2. Right? So we'll substitute. What is x1 of 0? See, x1 of 0 is 1 into x2 of 1. x2 of 1 is 2 plus x1 of 1 is 2, x2 of 0 is this. So you'll have 1 plus x1 of 2. So x1 of 0, x1 of 1, x1 of 2 is 3. This multiplication as it is, x2 of 0, 1, 2, 3. It is this 2 plus, see, x1 of 3 is 4. So I'll substitute 4. x2 of 2, 0, 1, 2 is 2, right? So see, this was x2 of 3, right? So 0, 1, 2, 3. So this is your 1, right? Okay, now we'll do 1 2s are 2 plus 1 2s are 2, 3 1s are 3 plus 4 2s are 8. So your answer is 15. So y of 1 turns out to be 15, right? So we are done with y of 0, which was 17, y of 1, which turns out to be 15, right? Next, we'll do y of 2, right? So we'll retain the main equation. I'll just go on substituting n values as 2, right? So y of 2 is equal to x1 of 0 into x2 of 2 minus 0 to base 4, x1 of 1, x2 of 1 minus 1 to base 4, x1 of 2, x2 of 2 minus 2 to base 4, see, plus x1 of 3, x2 of 2 minus 3 to base 4, right? Okay, here also this is 2, right? Now let us simplify this. So x1 of 0, x2 of 2 to base 4 plus x1 of 1 into x2 of 2 minus 1 is 1 to base 4 plus x1 of 2 as it is. This becomes x2 of 0 to base 4 plus x1 of 3 as it is. This becomes x2 of minus 1 to base 4, right? 2 minus 3 is minus 1. Right? We'll still simplify this. I have x1 of 0, x2 of 2. Right? We can remove that base 4. Next, x1 of 1, x2 of 1. We'll remove this base 4. x1 of 2 into x2 of 0, we'll remove this base 4, plus x1 of 3 into x2 of, see, now you do first 4 minus 1, that is 3. Now you remove this base 4. Right? So we'll just go on substituting the values. X1 of 0. See, x1 of 0 is 1 and x2 of 2. This x2 of 0, x2 of 1, x2 of 2 is 2. Plus x1 of 1 is 2 into x2 of 1 is 2. Plus x1 of 2 is 3 into x2 of 0 stays to be 1, plus substitute for x1 of 3, which is 4, into x2 of 3, which is 1. Okay, so this becomes 2 plus 4 plus 3 plus 4. So this is 8, 9, 8 plus 3, 11, 12, 13. Okay, so y of 2 works out to be 13. Right? So we are done with y of 0, which was 17, y of 1, which turned out to be 15, y of 2 is 13. Now the last one, we need to substitute n value. So now I am left out with finding out the values when I substitute n as 3. Right? So we'll substitute n as 3. So this becomes x1 of 0, x2 of 3 minus 0 to base 4, plus x1 of 1, x2 of 3 minus 1 to base 4, x1 of 2 into x2 of, see, I am substituting values of n, 3 minus 2 to base 4, plus x1 of 3, x2 of 3 minus 3 to base 4. So that is, I'll simplify this, x2 of 3 to base 4, x1 of 1, x2 of 2 to base 4, x1 of 2 into x2 of, see, 3 minus 2 is 1 to base 4, plus x1 of 3 as it is, x2 of 3 minus 3 is 0 to base 4. Right? So we'll substitute x1 of 0 is 1, x2 of 3 is 1, plus x1 of 1 is 2 into x2 of 2 is 2, plus x1 of 2 is 3, x2 of 1 is 2, plus x1 of 3 is 4, x2 of 0 is 1. Right? So this is what 1 plus 2 2s are 4, 3 2s are 6, 4 1s are 4. So when I add up, it answers to be 6, 4, 10, 14, 15. Right? So this is my y of 3. Therefore, y of n, which is 4-point circular convolution of x1 of n and x2 of n, is given as 17, 13 and y of 2 and 15. Right? Just see what was the value of y of 2. Right? Okay, I don't have it here. Okay, y of 0 was 17. Right? So just see what was y of 2. This would be your final answer. Right? So this is the circular convolution using time domain approach. The next video will be sharing with the circular convolution using matrix method, followed by circular convolution using concentric circle method, and the important one is Stockham's method. So stay tuned for the videos.